Hello everyone, I'm Bhavna Singh. Welcome back to Insightonomics. So let's start the topic for today without a further ado. In this video, we are going to explore the concept of elasticity of substitution with respect to consumers equilibrium. Okay, so in this case I'll be explaining the definitions of this elasticity of substitution, and I'm also going to derive an expression, a mathematical expression based on Cobb-Douglas utility function for this elasticity of substitution. Okay, so start करते हैं इसको. First, what is elasticity of substitution? ES. Okay, in short it is ES. So it is the ratio of percentage change in ratio of good y to good x, okay, divided by percentage change in MRS. So it is the ratio of percentage change in y to x with the percentage change in MRS xy, okay. So इसको हम लोग ratio of good x to the good y as a result of a change in the marginal rate of substitution between good x and good y. Your MRS represents the slope of your IC. Slope of your IC. Slope of IC. So as a result of change in the slope of IC, how this change will affect the ratio between good y and good x is depicted based on the elasticity of substitution, ES. Okay. So what does this depicts, and what is the difference between MRS and this ES? The basic difference is this only, that your ES represents like at what ease a consumer can substitute between the good Y and good X. It represents that like how, like ये बोलता है कि एक कंज्यूमर के लिए कितना इजी है ये दोनों गुड्स के बीच में सब्स्टिट्यूट करना. लाइक अगर उसको एक यूनिट गुड एक्स का कंजम्पशन बढ़ाना है तो वो कितनी इजी तरीके से गुड बाई का सेक्रीफाइस कर सकता है, उसके लिए कितना इजी है सेक्रीफाइस करना. सो दिस कम्स अंडर दिस इलास्टिसिटी ऑफ सब्स्टिट्यूशन. एमआरएस ये बताता है कि व्हाट इज द रेट ऑफ सेक्रीफाइस ऑफ गुड बाई फॉर एन एडिशनल कंजम्पशन ऑफ गुड एक्स. कि आपको एक यूनिट एडिशनल कंजम्पशन करना है तो आपको कितना सेक्रीफाइस करना पड़ेगा बाई का. ओके, इट डज नॉट टॉक अबाउट हाउ इजी फॉर अ कंज्यूमर टू सेक्रीफाइस इट. ओके, this is the basic difference between MRS and ES. So in expanded form we'll write this particular function as ES like our others elasticity formulas, del YYX, sorry, to the del MRS. There is change in YYX as a result of change in MRS, and your MRS divided by YYX. This is the formula for ES. Now, in order to find out its mathematical derivation, we can also write this formula in log terms, okay? Which is similar to this expression, like d log YYX to the d log MRS, okay? So these are the same expression, different expression for the same concept. We are going to use this concept in order to derive the mathematical expression for our ES, okay? So based on the different utility functions, elasticity varies because in case of perfect substitutes your MRS is constant. So in this case there is an immense scope for substitution between good x and good y because both are the perfect substitute for each other. तो उस केस में हमारी elasticity of substitution बहुत ज्यादा हाई रहती है. बट इन केस ऑफ कॉम्प्लीमेंट्स वहां पे सब्स्टिट्यूट करना इज नॉट दैट इजी, तो उस केस में आपकी जीरो रहती है. इन केस ऑफ परफेक्ट कॉम्प्लीमेंट्स योर ES मस्ट बी जीरो बिकॉज सब्स्टिट्यूट करना पॉसिबल ही नहीं है बिकॉज बोथ द गुड्स आर कंज्यूम in a fixed proportion एक साथ. Okay, so now we have to derive a mathematical expression for, let me also write this. ES depicts that at what ease A consumer can substitute between good X and good Y. Between good X and good Y as a result of change in rate of substitution. That is MRS. Okay. So इसको first like graphically देखते हैं. Then we will derive an expression for Cobb-Douglas utility function for ES. Okay. This is your budget line. This is your indifference curve. The tangency between these two represents your equilibrium. This, and at this point you are consuming this X star and Y star units of good X and good Y. Okay. Good Y. अभी क्या हुआ आपका MRS चेंज हुआ. So you have to look at this in this way. Let me draw a different graph. Okay. This is the curve. So you know at this particular point and at this point. Okay, this is point A. This is point B. At this point, let me draw like this, different color. Okay. Here you have good Y, and on this axis we have good X. Okay. So at point A, you are consuming more Y, less X, right? But at point B, you are consuming more good X and less of good Y. Why? Because at point A, your MRS is greater than your MRS at point B. At point A, your slope of IC is higher than the slope of this at point B. So at this point, you are consuming more good X. Like, let me draw. At this point, you are consuming Y1, X1. You have bundle for X and Y, which is equals to X1 and Y1. Okay. At point B, you are consuming Y2 and X2. So at point B, your bundle for X and Y is X2 and Y2. Okay. Based on MRS, your MRS at this point is higher than the MRS at point B. Why? Like earlier आप A point पे इक्विलिब्रियम पे हो, आप Y ज्यादा कंज्यूम कर रहे हो, X जो है कम कंज्यूम कर रहे हो. अभी आपका जो है स्लोप चेंज हुआ. अभी स्लोप आपका ये था MRS at point A, अभी आपका स्लोप चेंज हो गया. Because we are looking at this expression based on that only कि अगर आपके MRS में change होता है, then how easy for a consumer to change to substitute between these good X and good Y, right? तो आपका MRS change हो गया from point A to point B. Okay. अभी in order to maintain an equilibrium you have to change this combination. तो आपने Y कम कर दिया, X बढ़ा दिया. But elasticity of substitution ये बोलती है कि एक कंज्यूमर के लिए कितना easy है to substitute between good X and good Y with a change in MRS. Okay. ये डिपेंड करता है आपके यूटिलिटी फंक्शन किस टाइप का है. अलग अलग टाइप के यूटिलिटी फंक्शन में और अलग अलग टाइप के गुड्स में ये वेरी करता है इलास्टिसिटी. ओके. इन केस ऑफ नॉर्मल गुड्स और यू हैव Cobb-Douglas यूटिलिटी फंक्शन, आपकी इलास्टिसिटी 1 आता है एंड लाइक वी विल लुक फॉर इट. सो अल्टीमेट इन वन वर्ड इट्स लाइक Y1 से Y2 पे जाना कितना इजी है कंज्यूमर के लिए विद द फॉल ऑफ दिस MRS. ओके. MRS A से B पे पहुंचा, आपको Y1 से y2 पे जाने के लिए कितना इजी, सॉरी, फॉर अ कंज्यूमर ये कितना इजी है, मूवमेंट फ्रॉम y1 टू y2 एंड x1 टू x2. दिस इज ऑल अबाउट कम्स इन इलास्टिसिटी ऑफ सब्स्टिट्यूशन. अब मैथमेटिकल डिपिक्शन देखते हैं बेस्ड ऑन Cobb-Douglas यूटिलिटी फंक्शन. सो वी हैव बीन गिवन अ Cobb-Douglas यूटिलिटी फंक्शन u इज इक्वल्स टू x हाफ y हाफ. ओके, सो हम लोगों को इसको MRS के टर्म्स में डिराइव करना है फर्स्ट. सो MRS इज इक्वल्स टू mu(x/mu)y. सो mu(x) के लिए डिराइव करेंगे पहले, विच इज द पार्शियल डेरिवेटिव ऑफ u विद रिस्पेक्ट टू x. सॉल्व करेंगे x के रिस्पेक्ट में, 1/2 आगे आएगा, x 1/2 माइनस 1, y एज इट इज रहेगा क्योंकि x के रिस्पेक्ट में डिफरेंशिएट कर रहे हैं. नाउ फॉर mu(y), सिंपल, इट इज अ पार्शियल डेरिवेटिव ऑफ u विद रिस्पेक्ट टू y. अगेन y के रिस्पेक्ट में डिफरेंशिएट कर रहे हैं, x एज इट इज रहेगा, x हाफ y 1 हाफ माइनस 1. नाउ we'll divide this in order to get mu(x) and mu(y). हाफ से हाफ कैंसिल आउट हो गया. Okay, now we'll manipulate this particular term. Let me use different color. So you got x half into x minus 1 into y half. Similarly, you are left with x half, y half, y minus half. ये एक्सप्रेशन सेम है, कैंसिल आउट हो जाएंगे. यू लेफ्ट विद x minus 1, y minus 1. सो इसको इंटरचेंज करेंगे, यू विल गेट MRS इक्वल्स टू y(x). This is your MRS. Okay. Now, in order to just manipulate it in terms of this elasticity formula, what we will do, we'll take log of this particular term. So take log both sides. Okay. Log MRS. So like in this form, जब हम इस फॉर्म का log लेते हैं तो ये हो जाता है log of a by b. You'll get log a minus log b. Okay, जब log फॉर्म में लेते हैं इसका तो so we'll get log y minus log x. Okay, और सिंपली इसको इंडिविजुअली भी लिख सकते हैं, अलग अलग लिखने की जरूरत नहीं क्योंकि हमें y(x) के फॉर्म में ही लेना है. Okay, now we will differentiate this particular term log y(x) with respect to MRS, so that we will get the formula for elasticity of substitution. So differentiate log y(x) with respect to log MRS. Okay, so ये ओवरऑल MRS का पावर 1 है, ये 1 है, तो इसको डिफरेंशिएट करेंगे, we will left out with log y(x) log y(x) is equals to 1, right? And as we know, हम लोगों ने फॉर्मूला डिराइव किया था. This is one of the formula for elasticity of substitution, that d log y(x) and your MRS. We have the same formula. So this whole term will equals to ES. So we got the final expression for our ES. Your elasticity of substitution in case of Cobb-Douglas utility function will equals to 1. Okay. So what is the interpretation of this? It means 1% change in MRS will leads to the 1% change in ratio of y(x). This is the interpretation of this particular value, that your elasticity of substitution is equals to 1. And in this case, as we have already derived in case of Cobb-Douglas utility function, you got this convex to the origin, this type of demand curve, sorry, indifference curve. This is your IC. So in case of Cobb-Douglas function, you will get this type of IC whose elasticity of substitution is equals to 1. Okay. So we are done with this video. Thank you so much for watching our content. If you find it helpful, make sure to like, share and subscribe our channel. And if you had any queries and observations, please do let us know on our comment section. And you can also join us on our Telegram channel where we'll upload all the links of the YouTube videos and also provide the PDFs and important book notes with respect to economics. Thank you.